Okay, dear student, let us see what is there in this question. A rocket travels a distance of 3 kilometers in 10 seconds. What is the order of magnitude of the speed of rocket divided by the speed of light in vacuum? So kind of easy question. Let's see. So first of all, we will find the speed of the rocket, and that is given by 3000 meter divided by 10. So that can be taken as 300 meter per second. And what is the speed of light? 3 into 10 raised to power 8 meter per second. We can now find the ratio. That will give you 100, and clearly your answer is this. So clearly the answer will be B. But there is one piece of information, additional information, that I can give you here, that if in some cases, let us say like there is no problem here, this can be written as 1 into 10 power negative 6. But let us say that you were getting something about like 32 10 raised by negative 6 ratio. So if this was the case, the order will not be taken as 10 raised by negative 6. The order will be, it can be finalized only if there is a decimal like this. There is only one position that is allowed to have, like it is allowed to exist like this, and so this will become 10 raised to power negative 5. So in this case the order will be 10 raised to power negative 5. So I was expecting that the question would be somewhat like this. You would be getting an answer in 2 digits here, but then there will be, the tricky part is that you have to convert it into decimal, and then only you would be in a position to tell what is the order of the magnitude. But that is not the case here, clearly, because it is only 1.0, you can say. So definitely the answer is 10 raised to power negative 6. So answer is B. So this is how we do this question. All the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. The variation with time of the displacement of the object is shown. What are the average speed and average velocity of the object over 10-second time interval? So you have to find the average speed and the average velocity. Let's see. So the only concept that is used here is that the average speed will be equal to the total distance divided by total time. And if it is about the average velocity, we will talk about the total displacement divided by total time. Let us first go for the average velocity because it will be easy. So after 10 seconds, you can clearly find what is the displacement. So displacement is 8. So this is 8 divided by 10. So your answer is coming out to be 0.8 meter per second. But what about the average speed now? For average speed, you have to find the total distance. Now, what is the total distance? See, distance is just like what is the petrol that you are spending while you are traveling. Obviously, if you have gone to the market and you are coming back from the market to home, it's not like that now you are gaining petrol back again. It's not like that. So obviously you would be adding the distance when you go from your home to the market and then market to the home. So that distance will be added. So clearly here also, first the body is going up to 10 and then it is returning and it is going up to 2. So 2 is here and 10 is here. So it will be 10 plus 2, that is 12. So total 12 meter will be the distance that is traveled. So the average speed will be 12 divided by 10, and that will become 1.2 meter per second. So our answer is that for the velocity it will be 0.8 because it will be lesser, and for the speed it will be more than the velocity, which is 1.2. So our answer will be C. Let us see the mark scheme, and yes, the answer here is given as C. So this is how we do this question, dear student. Let us move to the next question now. All the best. Please share the video with your friends. Thanks for watching. Bye. Okay, dear student, let us see what is there in this question. A mass is suspended by a light string from the roof of a car, and car is accelerating up an incline. What is the free body diagram for the mass? So my dear student, there is a concept involved here. So you have to be very careful when I'm teaching this. This is the first time that I am looking forward to this kind of question because this is related with pseudo force, and usually these kind of questions are not there in IB, but this time they have asked. So let's see. So there was a case that we did for the lift, isn't it? When we were talking about the apparent mass, apparent weight, sorry. So apparent weight. So that kind of concept is given a name, pseudo force. Pseudo force is a force, as the name suggests, it is a force which is actually not present in the situation, but the effect of the force is there. Okay, just like you can say, like you are traveling in a bus and you are standing in the bus like this, and so the bus driver applies an abrupt brakes. So what is happening? The force is applied on the bus, but you are falling in front of it, isn't it? Like you are falling like that. So when you are falling, it feels like somebody pushed you. There is an effect that somebody pushed you, but nobody has pushed you. It is the bus which is getting, which is stopped. The force is applied to the bus. So if bus is stopping and the acceleration is there, retardation of the bus is taking place, that is an obvious thing because bus is having a brake. But what is happening to us? We are thrown in the forward direction. This kind of force is called pseudo force. So the force is not there, but the effect of force is there. That is pseudo force. Similarly, in this kind of case, when a car is there and this car is moving with an acceleration a, so there is a body which is present here, even this will be experiencing a force. The mass of the body is a. Now this is the characteristic of pseudo force, that the force which is there, it is given by the mass of the bob and the acceleration of the vehicle. So mass of the vehicle is capital M. I just want to clarify this, that in this formula you are using M, which is the mass of the bob, and A is the acceleration of the vehicle. This is, like it's very a different kind of a force. If you people have purchased the subscription on the YouTube channel, you can even refer to the video lecture for the pseudo force that I have delivered on the online course that is available. You can please watch that video to know even more details there. Okay, so this is the pseudo force, and because of this body is experiencing a force in the downward direction like this. Let us say the acceleration here is a, and it is clearly written that the car is accelerating, so this acceleration is positive, there is no doubt about that. So there will be a force in the backward direction, weight will be there, and the tension will be there. Now with the help of this question, I am giving you the concept of pseudo force, but there is a catch here. Let me tell you what. Now we will see the options, and once you see the option, clearly you feel like D is the correct answer, because the pseudo force is shown here, weight is shown here, and the tension in the string is shown here. On the surface, it seems that D is the correct answer. But my dear student, D is not the correct answer. Why? The reason is that when you talk about the free body diagrams, we are showing only and only the real forces. Pseudo force is not a real force. Nobody has pushed you in the bus. You have the effect as if somebody has pushed you, but nobody is pushing you. So there is no force which is acting on me. So what are the forces which are acting? Definitely the weight is acting, and definitely the tension is there. These are the two real forces. This force is there, but we will not be showing this in the free body diagram. We would be using the concept of the pseudo force if there will be some numericals. If you want to find something, yes, you would be using it, and this force will be really very helpful. This concept is really very helpful, but it is not shown in the free body diagram. So clearly the answer will be either B or C, but still we are confused whether it will be B or C. Now, what are the changes here? You can clearly see that the tension is shown bigger, weight is lesser here. Here, the weight is bigger and tension is lesser. Clearly, the answer will be B. Why? Because the body is not experiencing any motion in the vertical plane. It means that there has to be an equal and opposite force. So, this will be the component of tension T, which is equal to the weight W. So T cos theta should be equal to the weight W. That is why these two forces will cancel each other and the equilibrium will be maintained. Obviously, this tension T got to have more magnitude than the weight W, and that is why the answer will be B. So this is how we do this question. My dear students, please do not get confused. I have used this opportunity to explain you the phenomena named pseudo force, although that concept is actually not used in solving this question. So please beware, and the answer should be B. Let me show you the answer in the mark scheme. Question number 3, the answer given is B. So this is how we do this question. Thanks for joining. Thanks for watching the video. Please join the YouTube channel if you want to access the paper two questions and also the online course that is very important now. And this is paper one question. Everything is free. I would be doing all these questions. Thanks. Bye. See you in the next video. Okay, dear students, let's see what is there in this question. An object is traveling with the velocity 5. The object then accelerates to 15 meter per second in the same direction. What is the variation with time of the acceleration of the object? Okay, that's a very cool question, I would say, because the data given is very less. What is the variation with the time of the acceleration? So the question itself is telling you that might be that acceleration is a variable acceleration. If it is a variable acceleration, just like the graphs shown in A and B, SWOT equations cannot help you. Very good. So we cannot use the SWOT equations here. So we have to create another concept. Let's see. So we are always, like, one thing is always sure, that in acceleration time graph, the area under the curve is going to give you the change in velocity. So change in velocity is clearly known as 15 minus 5, and that is 10. So we have to find the area under the curve, and for whichever graph the area will be equal to 10, that will be our answer. Let's see what is this. It is a triangle here, so area will be half into base into height. Height is 10, so this is 5. Clearly the area is 25 units here, so this is wrong answer. So A is wrong and B is wrong. Clear? Let us now move to C and D and find the areas. So in the case of C, this is a rectangle. The area is like length into base. This is 2. 4 minus 2 is 2, and this is 10. So area here is 20. Even this is wrong. And this is 2, and this is 5 value here. So 5 2s are 10. So D is the correct answer, and this is how we are going to do it. Very tricky question, I would say. IB has created a very beautiful question, no doubt about that. So this is how we do this question. Let's verify it from the mark scheme if the answer is D. This is question number 4, and yes, the answer is D. This is how we do this. Thanks for watching the video, students. Please share the video with all your friends, and please join the YouTube channel. All the best. Bye. See you in the next video. Okay, dear students, let's see what is there in this question. The angle theta between the ramp and the horizontal surface slowly increases from 0. An object on the ramp does not slide as theta increases. So it does not slide as theta increases, and theta is having a variable value. So there was a topic that we have done in the topic of friction, and the name of the topic is angle of repose. So all the students, those who have joined my private classes, they might have done this. They might know what is angle of repose. This is not given in the books for IB, I believe. And if you people have joined the YouTube channel, you can refer to this topic in the online course that I have provided there. But otherwise, there is a chance that you do not know what angle of repose is. Let me explain you what it is. So what is happening here is this ramp, when it is increasing its value, so there will be some theta max at which the object will start sliding. So that is called the limiting case. That will be known as limiting case. Limiting case means that it is the limit of the theta. So beyond that, the object will not be static and object will start sliding. So the object will start sliding. So that will be the limiting case. So now what we do, we are going to understand this first of all. So this is the weight. So two components will be created here. This theta will always be equal to this theta. So this will be mg cos theta. This will be mg sin theta. So now the normal reaction will be equal to mg cos theta, and friction is in the backward direction. Now be careful. We know a formula which is Fs max, and that is given by mu normal reaction. So mu s, the normal reaction n is equal to mg cos theta. So Fs max is equal to this. So we can very well say that the frictional force of an object is, so the frictional force will not be constant, it will not be negligible, whether it will be proportional to sine theta or cos theta. Okay, so my dear students, try to understand this. We can clearly see that the friction is directly proportional to cos theta, so there is a chance that you will definitely go for the topic, to the point C, but the C is not right answer. Let me tell you why. Because this theta is not theta max. This theta is not theta max. So what is happening? Static friction is a friction which is applied on a body, which applies on a body until the body starts moving. So this is the case, exact case for the static friction. And there is another friction which is known as limiting friction. Limiting friction is the maximum possible value of friction between the two surfaces. That is given by this. So this is the maximum possible value of friction. It is not the actual friction which is acting on the body. It's a very deep concept, because that is not given in the books also. And I tell you, your books are teaching you only static friction and the dynamic or the kinetic friction, but they are not even talking about the limiting friction. So there is a confusion between the concept of static friction and limiting friction to IB people, to IB students, to IB teachers might be. So that is why be very careful here. I'm going to tell you this concept. So until the body is moving, the friction is Fs. It is lesser than Fs max. Fs max is given by mu s into n. So what about the magnitude of this? There is no formula for that. Like this formula, let us say this formula is giving you the value 5 Newton. It means that maximum possible value of friction is 5. But what is the friction between body and the surface now? It could have any value, 1 Newton, 2 Newton, 3 Newton. It could have any value, but it will be lesser than 5. But what value will it be? We don't know. So we have to create a formula for that. I have given all these things in my theory lectures, in my online course, by the way. But in this question, we have to see. So this friction is found to be equal to the applied force, which tries to move the body. Now, in this case, mg sine theta is the force which is trying to move the body. What does it mean? It means that the friction, which is instantaneous friction, which is acting now, we don't even have a clue about it, that friction is actually equal to the force which is trying to disturb the equilibrium, which is mg sine theta. So this friction is directly proportional to sine theta, hence the answer will be D. And I'm damn sure that 99% of the students will be wrong when this question was asked to them in the question paper. It's a very beautiful, very tricky question, no doubt about that. So the answer for the friction will be mg sine theta, provided they are not teaching you angle of repose in their books or in their classes. They're not telling you about the limiting friction. They do not tell you that what is the static friction and how to find the magnitude of a static friction. So this question is a $1 million question, no doubt about that. Okay, dear students, so this is how we do this question. So the answer will be D. Let us see in the mark scheme if the answer is D. Yes, it was question number 5, and yes, the answer is D. So this is how we do this question. Please share the video with all your friends, and try to join the YouTube channel if that is available in your country. That is very, very important for you to score well. Okay, dear students, all the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. A spring of negligible mass is compressed and placed between two stationary masses. One is small m, another is capital M. The mass capital M is twice of that. So that is already given here. The spring is released so that the masses move in opposite directions. What is kinetic energy of mass small m divided by kinetic energy of capital M? So my dear students, in this question, like we have done a similar question that is also available in on YouTube already. So IB has asked a similar question to this in earlier papers also. So again, I'm going to do this. So what is happening in this is basically an expansion is taking place here, and this question can be taken to be we will be applying the principle of conservation of linear momentum. This is compared with the collisions. So these are known as super elastic collisions. Beware, there is no collision there, but still it is known as super elastic collision. Elastic collision is in which energy is conserved. Inelastic collision is in which energy is lost. Super elastic collision is in which energy is created. So earlier, before that, before when we have not left it, the total energy is zero, like the masses are not having any energy. But after that, kinetic energy of the masses is created from somewhere. That is why it is known as superelastic collision. And this can also be compared with the case of explosion. Like the initial kinetic energy is zero, final kinetic energy is not zero, like that. So we would be applying the principle of conservation of linear momentum first of all. So initial momentum for both of the body is zero, equal to the final momentum after you have left them. So let us say this body is going back with v1, this body is going here with v2, and so let me take this as v2 and this as v1, because I'm going to take this as positive and this direction as negative. So the momentum will be mv1 minus small m v2. Accordingly, we can find the ratio. And what is the ratio of the kinetic energy here? So this can be written as half m1, sorry, half m v2 square divided by half capital M, which is 2m, into v1 square. This is the ratio that we want to find. Half and half is getting cancelled out, m and m is also cancelling out. So the ratio that we want to find is v2 divided by v1 whole square. This is the ratio that we are going to find it from here. So this is going to the other side. This will become 2m v1. We want to find v2 by v1. So v2 divided by v1 is equal to 2, and this is the value that we are going to substitute it here. So it will be 2 into 2. So our answer will be C, and the answer will be 2. So this is how we do this question. What are we doing it here? Number one, we have applied the principle of conservation of linear momentum. We found the ratio of the velocities, and then we go for conservation of energy principle, like the kinetic energy is coming out of this. So it is compressed earlier. There is a potential energy which is given into this spring, that is converted into the masses. But we are not going for that kind of conservation of energy principle, because the values are not given, x is not given, so we are not going there. So this is how we do this, and the answer will be 2, will be C. Let's see the mark scheme. Question number 6. Yes, the answer is C. So this is how we do this question. Thanks for joining. Please share the video with all of the students. Please join the YouTube channel if that is available in your country. All the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. An object of mass m is accelerated vertically upward by a motor at a constant acceleration. So acceleration is constant. The object is initially at rest and reaches a vertical speed of 4 in 2 seconds. So here the speed is 4, here the speed is 0, and the time taken is 2 seconds. So clearly kinetic energy has been added into the system. What is the average power output? So my dear student, first of all, whenever we think of power, the formula that come into our mind is F into V. So we say that the power will be equal to F into V. But this formula is not valid in this scenario. This formula is derived under one condition, that the body is moving at a constant velocity. If the body is not moving at a constant velocity, this formula is not valid. We cannot apply this. And clearly in this case, the body is getting accelerated. If it is accelerated, the velocity is not constant, hence this formula is not valid. Yes, you can find the instantaneous power at some instant, because the velocity will be given as 4. You can find, like, okay, this much is the force, this much will be the power used instantaneously, but that will be a variable. It is going to change at every instant. That is why only we are having a concept of average power, because power is not constant. But what are we going to do now? So what we do, there is another concept. The power is also defined as change in energy by change in time, or rate of doing work, isn't it? So we have to find what is the total work that is done, and what is the total work, or what is the total change in energy. Both of them, like the work is equal to the change in total energy here. So the kinetic energy is also changing and the potential energy is also changing. So in this question, first we will find the change in kinetic energy. That will be half m v square minus 0. So half, mass can be taken as capital M, V is 4, so that will be 4 square. This is the change in the kinetic energy. Let us go for the change in potential energy now. Change in potential energy will be clearly mgh, but the height is not known, so we have to find the height. And that we will be using S is equal to ut plus half at square, but for that A is not known. Let us go for V square minus U square is equal to 2as. Now, this is the application of Stewart equation. We got to have the sign conventions. Let us say that the upward direction is positive, downward is negative. No, but we should not be going in this also, because we do not know the acceleration, and gravity is also there, so that will be really confused. So we have another formula, the fourth formula for the Stewart equations. You must be remembering it. S is equal to U plus V divided by 2 into T. I think this is the best formula that we can use here instead of going for acceleration. So U is 0, V is 4, divided by 2, and time is 2. So this will be 4 meter. Yeah, I would be using this now. So 4 meter. So M, here there will be gravity, no doubt about that. So you can take it as 10, and this is 4. So it will be 40 m, and this will come out to be 8 m, isn't it? Because this is 16. So you divide it by this, it will be 8 m. So the potential energy is 40 m. So it means that the total energy that was added into the system is 48 m. But we want to find the power. So power is total energy divided by the time, and which is clearly 48 m divided by the total time, which is 2 seconds. So our answer will be 24 m. So your answer will be B. Okay, so this is it. Let us see what is the correct answer from the mark scheme, and my answer is B. And yes, for the question number 7, the answer is B. This is how we do this question, and this is a very beautiful question. It's a very tricky question, no doubt about that. And thanks for joining. Thanks for watching the video. Please join the YouTube channel if you want to access paper 2 questions. And you can access the online course also. That is very, very important for your final examinations, isn't it? Okay, dear students, all the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. An object is released from rest and it slides to y. The vertical distance between x and y is given as 10. During the motion, 20% of the initial gravitational potential energy is lost as friction. What is the speed of the object at y? So it's clear cut, clearly the conservation of energy principle here. So the total energy is mgh, and 20% is lost. It means that the 80% of this will be remaining with y, and that will be converted into half mv square, and from there we will find the value of the velocity. So I think this should be the answer. Let's see. So 100 gets cancelled out. So this is 16 into g is equal to v square. So v is 4 square root g, and yes, the answer is C. So this is how we do it. It's simple conservation of energy principle. So this is the energy with which you started. 80% is the energy which is remaining, 20% is lost due to friction, and the answer is this. So the velocity is 4 square root of g. So this is how we do this question. All the best. Bye. Okay, dear student, let's see what is there in this question. A fixed mass of ideal gas expands slowly at constant temperature in a container. So the mass is fixed, ideal gas expands at constant temperature. So temperature is also constant. 3 statements about the gas molecules during the expansion are: they collide with the walls of the container at a reduced rate. They travel further on average between each collision. Now, their average kinetic energy decreases as the gas expands. Which statement is correct? Okay. So first of all, my dear students, the point to be noted here is that the mass is fixed, the ideal gas, it expands, it means volume is increasing. So point 2 is absolutely correct, because volume is increasing and mass remains the same, it means number of molecules are the same. So obviously now the distance between the molecules, it has increased, so they travel farther on average between two collisions. There is no doubt about that, because now the volume is bigger. Now their average kinetic energy decreases, so this is wrong. 3 is wrong. Why? Because it is a constant temperature process, isothermal. There is no change in the internal energy, or I can say because the temperature is constant, there is no change in the kinetic energy. Because from our topic, we know that the average kinetic energy has a formula which is 3 by 2 kBT. So kinetic energy is dependent only on temperature. So if the temperature is not changing, kinetic energy cannot change. So 3 is wrong. So if 3 is wrong, 3 is wrong, 3 is wrong, clearly the answer will be A. But let us go for the first also. They collide with the walls of a container at a reduced rate. Now this is actually the microscopic version of pressure. How do we define pressure at microscopic level? So we say that the pressure is because of the collisions of the molecules with the wall. So PV is equal to nRT, temperature remaining constant, all of these are constant. Volume is increasing means pressure is reducing. So if pressure is reducing, clearly that the collisions are now there is a reduced rate. Obviously, there are less number of collisions which are taking place. So clearly, the point number 1 and 2 are correct. So A is the correct option. Let us see what is there in the mark scheme. This is question number 9 we were referring to, and yes, the answer is absolutely correct. This is how we do this. Please share the video with all, and please do not forget to join the YouTube channel. All the best. Bye. Okay, dear student, let's see what is there in this question. A balloon of volume V contains 10 milligram of ideal gas at the pressure P. An additional mass of the gas is added without changing the temperature of the balloon. This change causes the volume to increase to V and the pressure is increased to 3P. What is the mass of the gas which is added into the balloon? Okay, dear students, so this is simple ideal gas equation will be used here. So PV is equal to nRT. All the symbols having this usual meaning. Pressure, volume, N is the number of mole. Number of moles can be written as mass of gas in grams divided by the molar mass into R into T, and this is P and this is V. So this is how we can write it. M is the molar mass of the gas. Like for example, in the case of hydrogen, that will be if it is H2, isn't it? So that can be taken as 2, yeah, accordingly. So that is the molar mass. So, but it will be a constant value. This is what I want to say. So let us say earlier the mass was M, which was 10 milligram, by the way, 10 milligrams into RT divided by M, and this is P into V. So this is case number 1. Now what is happening? We have added some mass into it and the pressure becomes a 3P. So our new equation will be 3P and the volume is 2V and some mass is added here. And this is RT divided by M. It is like that. And now we want to find this M. So what we do, we can divide these two equations, or we can find the value of PV and we can equate these two values. So this can be written as 3 2 are 6, so 6 PV. So this PV can be substituted here. So the equation becomes 6 into this is equal to this value. Other things can be easily, we can get rid of them. The only thing is that the mass should be in grams, neither kgs nor milligrams. It has to be converted into gram, otherwise all of the calculation will be wrong. So this is what is left here. So it becomes 60 into 10 raised to power negative 3 is equal to 10 into 10 raised to power negative 3 plus M. It means that M is equal to 50 milligram now. isn't it? 10 is going to the other side, 60 minus 10 is 50, and 10 to the power negative 3 is there. So the new mass that will be added is 50 milligram, and so C will be the correct answer. This is how we do this question. Um, okay, dear students, thanks for watching the video. Please share the video with all your friends, and also join the YouTube channel if you want to have the access to the paper 2 solutions and to the online course that I have given, which can really give you an edge for the preparation. Okay, dear students, all the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question now. A pipe containing air is closed at one end and open at the other. The third harmonic standing wave for this pipe has a frequency of 150 hertz. What other frequency is possible for the standing wave in this pipe? So we have to see now. Clearly, one end of the pipe is closed and one end is open. So in this case, we know that the general formula for this is given by N into V divided by 4L, because one end is closed and one end is open, where N can be only odd number. So even harmonics are absent. Even harmonics are absent. So only odd harmonics are present. So first harmonic could be there, the next will be the third harmonic, and the next will be the fifth harmonic. Likewise, you can even go for the sixth. And likewise, you can just go for the odd number harmonics. Even number of harmonics are not present, because this is a pipe which is closed at one and open at the another. It is like that only. So it says that the third harmonic, so the frequency 3, that is 3 times V divided by 4L, this value is equal to 150. So this will be equal to 3 times the fundamental frequency, that is the first frequency. Clearly, the first frequency will become 50 hertz, like 150 divided by 3. So it means that if you refer to the first harmonic, your frequency will be 50 hertz. For the third harmonics, it will become multiplied by 3. And for fifth, it will be multiplied by 5. And 5 5s are 25. It will become 250 hertz. For seventh, it will be 7 5s are 35. So that will be 350 hertz. And this is how it will keep on moving. The table we can create. These are all the possible frequencies for the standing wave in this pipe. Now, out of all these possible value, only 50 hertz is given in our options. Other options are not there. 50 will be correct answer, 250 will be correct answer, 350 would be the correct answer, but in our case 50 hertz is given. So according to this, the answer for this question will be B. So this is how we do this question. And also, my dear student, there is one more piece of information that I can share here. This is when one end is open, closed at one end and open at the other end. Many a times this formula is not written like this. So there is a catch. There was another question I remember. In this, like if you are going to write this like this, we have to say that n is an odd number. Otherwise, there is another fancy way of writing 2n minus 1 v divided by 4l, where n is the element of natural number, like this, or you can call it 2n plus 1. So it is known as the kind of n is all the natural number, but you would be using 2n minus 1. So sometimes the formula is given in this way, sometimes the formula is given in this way, but this way is definitely better, definitely easy to understand and apply in your question. So this is how we do this question. This is Professor Varun. Let us see the answers for this, by the way. Answer is okay, what question was that? I think it was question number 11. Yes, the answer for this is B. Okay, dear students, so this is how we do this question. Thanks for watching the video. Please share the video with all your friends. All the best. Bye. Okay, dear student, let's see what is there in this question. A longitudinal wave is traveling through a medium. The variation with distance d of the displacement x of the particles in the medium at time t is shown. Which point is at the center of the compression in this? So this is time and again this kind of question is repeated in our examinations, and uh, so many questions I have seen which are based basically on the same concept. So try to understand, this is a longitudinal wave, not a transverse wave, and how to read the graph which looks like a transverse wave, but it is belonging to longitudinal. How do we see that? Now, this displacement is positive and this displacement is negative. So all the points before this, they are having a positive displacement. Let us say that the positive displacement is towards right hand side, negative displacement is towards the left hand side. So it means that all these particles are going towards right hand side, and all the particles here, those who are having the negative displacement, they all are going towards A, isn't it? Like this particle, if I choose, this particle would be moving towards A, and the displacement will be given by this. Like this will be the length for the total displacement. For this much of the displacement, it is going towards A. Clearly, A is a point where compression will be there, because it is being pushed by both of the particles on either side. We can say, like on this side as well as on this side, they all are coming together and they are pushing this particle, like this point position A. So A is coming out to becoming a compression. What about the C point now? So these particles are going towards A, and all these particles, because they have the positive displacement, they are going towards they're going away from C. Clearly, this C is the rarefaction, isn't it? Or the expansion, you can say. Yes. Okay, and A is the point of compression. So our answer in this case will be clearly A. There is no doubt about this. Okay, dear students, so thanks for watching the video. This is Professor Varun. The answer for this video is A. Please start joining the YouTube channel if you want to access the paper 2 questions and the online course, which is like very important for us, isn't it? Okay, then all the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. Unpolarized light of intensity I and amplitude A passes through a polarizing filter. So the intensity here is I and the amplitude is given as A. What is the amplitude of the light transmitted by the polarizing filter? Okay, so first of all, it is a concept of polarization. What happens is that if this light is unpolarized, which can be shown like this, isn't it? So this is unpolarized light which is coming and which hits this point, so it becomes a polarized. So when it becomes a polarized, like let us say the axis is vertical here, so only the vertical outlet will be there. So this is the polarized light. So this polarized light has an intensity which is half of the unpolarized intensity. As a matter of fact, this is just kind of formula like that you can just remember. If this is an unpolarized light and intensity is I and it is polarized, the intensity divides by 2, so intensity becomes I by 2. But now here the amplitude was A, so we can say that intensity is directly proportional to amplitude square. So I can create a formula: I1 divided by I2 is equal to A1 square divided by A2 square. And the question is, like, what is the A2, which is after getting polarized? What will be the amplitude? We want to find that. So I1 here is I and I2 is I by 2. And here the amplitude is A, but this amplitude, which is A2, is a variable. We want to find A2 now. This and this gets cancelled out. 2 will go into the numerator. So this will be A square divided by A2 square. And accordingly, I can say that A2 square is coming out to be A square by 2. So A2 is coming out to be A square root 2. Clearly, D will be the correct answer for this question. This is how we do this. And the only piece of information that you need to remember for this kind of question is that if this is unpolarized light and it is passing through the polarizer for the first time, then there is no Malus law in this. Directly, the intensity is I and it is converted into I by 2. That's it. Okay, dear students, please share the video with all your friends. Join the YouTube channel if you want to access paper 2 questions. This is Professor Varun. Thanks for watching the video. All the best. Bye. Okay, dear student, let us see what is there in this question. An electromagnetic wave enters a medium of lower refractive index. 3 statements are made. Lower refractive index means that we can just assume a particular case that might be the light is coming out from water and it is entering into air. So this is the interface. Yeah. And this is the normal. where the light is incident and it is coming like this. Obviously, if it is going into a rarer medium, rarer means like the medium for which there is lower refractive index, and this will be denser, just like water, and this is, let us say, air. So it would be first of all bending like this, isn't it? It would be bending away from the normal, that we know. Now, one thing is clear, that whenever refraction is taking place at these kind of surfaces, the frequency doesn't change. So the wavelength of the wave has increased, the frequency has decreased. So 2 is definitely wrong. Frequency of the wave has decreased. Frequency doesn't change. Mind it, one thing, like what is the, how you can like remember this thing. Frequency is something that determines the color of the light. So let us say there is a red colored bulb there inside the swimming pool, and that light is, it is looking red. Even if you are out of the swimming pool, it is looking red, and even if when you are in the water, at that time also the light will be looking red only. So color is a function of the frequency, and color does not change means that the frequency doesn't change. So I'm giving you this context behind, just for that, for the sake of remembrance, that you would be able to remember this thing, that yes, frequency will not change, but what will change? Now in the air, the velocity increases. Here the velocity will be v, and here the velocity of the light will become c, and c will definitely be the maximum. Similarly, the wavelength is lesser, even the wavelength becomes more, it becomes bigger. So here it moves like this, and here the wavelength is bigger, it goes like that. So point number one, the wavelength has increased, is absolutely correct. The speed has increased, even that is correct, because that is what is the definition of refractive index. Refractive index is the ratio of the speed of light in air divided by the speed of light in the medium, and this is the rarer medium, so definitely the speed will increase. Anyways, so the answer for us is A and 3, so answer will be B, and this is how we do this question. Okay, dear students, thanks for watching the video. Please join the YouTube channel if you have yet not joined it. Yes, all the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. 3-point charges plus Q and negative Q are fixed at 3 corners of a square. What is the direction of electric field at the 4th corner? So what is the direction of the electric field at the 4th corner? Let us see. So this is plus Q, this is minus Q, and both of them are equidistant from this point. And this distance, like charge for this is plus Q, but distance is bigger, so the electric field strength will be lesser. But in the case of plus Q and the minus Q, the magnitude will be the same, direction will be different. So let us first concentrate on these two charges. So this charge will be producing an electric field away from it, and this charge will be producing an equal electric field but towards itself, like this. These will be the two values. So our resultant for this can be created, which will be like this, and that will be quite bigger. So I can now erase these two. So this is the resulting electric field because of this charge and this charge. And obviously, that is going to be like, because both of them were equal, this angle was supposed to be 45 degrees. So I can clearly say that this is the diagonal here. So this will be parallel to the diagonal. Okay, these two lines will be parallel to each other. I repeat my explanation here, just a moment. Positive charge is creating electric field like this. Negative is creating negative like this. Both of them have the same magnitude. So the net electric field will be at 45-degree angle with this. And that is why I say that these two, like the electric field and the diagonal, will be parallel to each other. So this positive charge now will be creating an electric field which will be kind of lesser in magnitude, okay, but 90-degree to this, because this is the diagonal like this. So it will be along this diagonal, it will be 90-degree angle, but it will be lesser. Clearly B will be the correct answer. A, C and D, they do not stand a chance. So A, C and D are wrong. B is the correct answer for this question. Nothing more. We have to think from this point of view only. There is no mathematics involved here. Okay, so this is how we do this question. If there is any doubt, you can mention that in comment section. Thanks for watching the video. Please join the YouTube channel if you want to access the online course, and if you want to access paper to questions. And once you join it, those videos do not have the advertisements also. So you can save your time by joining the YouTube channel. Okay, then all the best. Bye. Okay, dear student, let's see what is there in this question. Two resistors of equal resistance R are connected to two cells of EMF E and 2E. Both cells have negligible internal resistances. What is the current in the resistor labeled X? So you want to find the current in this. Okay. So there will be kind of two methods here. One is easy, straightforward, but it is more conceptual. And the other thing is clearly the Kirchhoff's law. You can just distribute the current in all the branches, and then you can use the tool like for the Kirchhoff's law, and you can find the value. I would be showing you both of the method. Let us first go for the method number one. Now, what is happening here is we can rearrange the circuit as this. Now, clearly, this is 2E, this is E. Now, this and this, they are in series, so it doesn't matter. We can change the order of these two equipments. So that resistance, I have taken it on the other side so that it becomes more relatable and more understandable. This is like this. Now, in this, I'm going to name these things. Now, let us say this point is A, B, C, D, and E and F. So they are all in kind of parallel series here, parallel connection here. So the potential difference across EF, like this and this, these two branches, they are maintained at the same potential. So it means that the potential difference across EF is equal to the potential difference across CD and is equal to the potential difference across AB. We can assume that, isn't it? And now we can, like, current is flowing from everything, okay, but still, because there is no resistance in this branch, so there is no problem. The potential difference will be 2E whether the current is flowing or not. That doesn't matter. But in this case, the potential difference across AB will be incorporating the resistance or also. So this VAB becomes the terminal potential difference from the point of view of this battery, and the potential difference across EF, it will be 2E because there is no other resistance. So we can say there is no internal resistance. So we can say that the potential difference EF will be equal to EMF of the battery. So this should be equal to EF, which will be equal to 2E. Now the terminal potential difference across this, we can imagine the direction of a current. Let us say this is the direction of current and current is coming out of it. If current is coming out of it, the terminal potential difference can be written as E minus IR, isn't it? Isn't it? Terminal potential difference E minus IR. This is equal to 2E. Accordingly, we can find the value of I from this. So negative IR is equal to E minus E, which becomes E. Clearly, I is negative E by R. Now, what does this mean? What does negative current means? We have just chosen the direction of the current in just kind of with our whims and fancies, isn't it? Like this direction was not given. We just assumed it. That might be that the current is going out, but that is not the case. The current is moving in the opposite direction. That is why the direction of this current is coming out to be negative from our equation. But the magnitude will be E by R. It means E by R is the correct answer, but the charging of the battery is taking place. Charging of battery is taking place with the help of a current of the magnitude E by R, and this would be having sending some other current, and we don't care about that. So this, otherwise, if you do not want to use this method, the only method left is Kirchhoff's law. So we have to go for Kirchhoff's law, otherwise we can't do it. So now after this method, I am going to provide you with the Kirchhoff's law also, so the interested students can continue watching, otherwise the students can move to the next video. Okay, let us now apply the Kirchhoff's law. So now we know that the answer is C. Now in the Kirchhoff's law, what happens? First of all, the step number one is that we will distribute the current in the circuit. So current will be distributed like this. Let me call this as I1 and let me call this as I2. So I2 current goes like this, I1 goes like this. So at this juncture, both of the currents will be added. So from this resistance, the sum total of I1 plus I2 current is passing through it into the downward direction. And at this junction, both of the currents are now separated and they are returning to the respective batteries. Okay, so this is how we have distributed. Now we can create as many loops as we want. We can create the equations and we can solve it. Let's see. First of all, let us go for, yeah, let us create all the equations, no problem. So this is the loop number one, this will be the loop number two, and let us apply the equations for the loop number one and loop number two. So loop number one, the battery, this is the positive terminal, this is negative terminal. We start from this. So negative terminal is coming first, so that will be plus 2e. And then here, this is R, but the current is I1 plus I2. So minus I1 plus I2 into R, because loop is also going downwards, current is also going downwards. So this is equal to 0 because we return back to the same position P. So this is the one equation. Now equation number two, from this loop, we are again starting from the rear end of the battery. So this is negative terminal first. So we would be adding the battery E. Then it goes for this. So that will be negative I2 into R. And then it goes for this. Again, the direction is the same. And then we reach the same point, equal to 0. So now how can we do? These are the two equations and you want to solve it for I2. So you can subtract these two. So this factor and this factor will get cancelled out, and we can create this equation. So let us subtract these two equations. So 2e minus e will give you e. This, okay, this, when you subtract this, these two will be cancelling out and you would be left only with this, by the way. Okay, how to make it more convincing? We can, yeah, we can find this value. This is equal to E. I substitute this value here. So this 2 equation will become like this. And this equation can be solved. So it will be minus E minus I2R. Clearly I2 is coming out to be negative E by R. So this much is the method. Like this is how you have to do it. And so this method could be a bit cumbersome and there is more chances of making some clerical mistakes or something. But if the other method is not clicking you in the examination hall, which is quite obvious, this becomes the only method that you have to employ. Okay, so more is your practice, better you are with these kind of questions. Simple. So let's see what happens in the examination hall then. Okay, dear students, thank you for joining, watching the video. Please join the YouTube channel if you want to access paper 2 questions and the online course. All the best. Bye. Share the video with all your friends. Bye. Okay, dear student, let us see what is there in this question. 2 secondary cells require recharging. Which circuit will recharge both cells? Okay, so this seems to be easy question. See, discharging of a cell means that the current will be like this, and charging of a cells take place when the current is entering into the battery. So when the current is going opposite, so opposite chemical reaction is taking place within the batteries, and hence the charging takes place. So clearly A will be the correct answer. Positive terminal should be connected with the positive terminal of the battery and the current will be entering into it, and that is why we can clearly see that the batteries will be getting recharged. So A will be the correct answer. In B, both of them will not be getting charged. In this will be getting recharged, but this is not. Here this will be recharged, this is not. So answer in this case is clearly A, no problem at all. Okay, dear students, let's see what is happening in the next question. All the best. See you there. Bye. Okay, dear student, let's see what is there in this question. A negatively charged sphere is falling through a magnetic field. What is the direction of magnetic force acting on the sphere? So what is the direction of magnetic force acting on a sphere? So we have done quite many these kind of questions now. And if you are following my YouTube channel, have you watched like the playlist for 5.4? You might have seen like there are so many questions that we have done on this, and I have also discussed the right hand palm rule so many times now, and that even in complete details. But let us do it once again. So right hand palm rule, there are like, this is completely my terminology, this is my hot favorite. I don't use Fleming's right hand or left hand or something, and I do not use any other law. I use right hand palm rule because it is quicker, easier, that is why, more effective. And I have divided this right hand palm rule into three. So if you are a member on my subscription plan, and you have accessed the online course that I am posting there, so you can find these videos and you can watch these videos, like what kind of rules am I talking about. But here, let me explain you this right hand palm rule type 2. So type 2 is about finding the force on a charged particle, like the positive charge is going or the negative charge is going, like that. So what happens here is like, now, like again, this is for three types. One is positive charge, then negative charge, and then electric current wire. So we would be talking about the negative charge. So the fingers be pointing, first of all, we would be using our right hand and keep it hard. It should not be like this, but it should be like this. Okay, so fingers should be pointing towards in the direction of magnetic field. It means from north to south. So magnetic field is towards right, so I can keep my fingers like this. Okay, and my thumb will be pointing towards kind of opposite direction of the velocity of negative charge. If it is a positive charge, then it will be the same direction. If it is negative charge, it will be in the opposite direction. So this is the magnetic field, like this, and electron is going down, but I would be keeping my thumb in the upward direction. So my palm is clearly looking towards the screen. It means that the force which is experienced here, that will be into the page, that will be going into the screen, so into the page. So the answer will be D. So I can write here that palm will give you the direction of force on negative charge. So be very particular. This is only and only applicable on negative charge. In the case of positive charge, we do not use the opposite direction. We use the actual direction of the velocity, which will be downwards. Okay, dear students, so this is how we do this question. Please refer to my old videos. Please refer to the playlist referring to the topic 5.4. Or if you are a new student, like in the new syllabus, then it will be in a different playlist, by the way. So you can find those things. You can go for the online course that I have posted. You can watch those videos to understand what is type 1, type 2, and type 3. Okay, dear students, this is Professor Varun. Thanks for watching the video. All the best. Okay, dear student, let us see what is there in this question. A mass on the end of a string is rotating on a frictionless table in the circular motion of radius r1 and undergoes an angular displacement of theta in time t. It means that they literally want to talk about the angular velocity, but they do not want to say that the angular velocity is omega. Instead, they're talking in the terms of theta and t. So this will be equal to the angle traversed divided by the time it has taken. The string tension is kept constant. Now the tension in the string is kept constant. So tension is acting like centripetal force. So I can say that the tension is equal to centripetal force, which is given by mr omega square. But the angular displacement of the mass increased to 2 theta in time t. So now the angular velocity is increased, but the centripetal force or the tension or the centrifugal force is not changing. And omega is increased. It has become double. The radius of the motion changes to r2. Okay, so what is r2? This is what they want. Okay, so in the second case, this t remains the same. Radius is r dash, but the omega is doubled. So it is becoming like this. So these two equations are equal to each other. One is equal to, clearly when omega is multiplied by 2, so this equation multiplied by 4, so radius will become 1 by 4, I believe. Yes, radius will be 1 by 4, isn't it? Omega is doubled. Yeah, the radius will be 1 by 4. I can show you here. M r dash 4 omega square is equal to mr omega square. So m and omega square are cancelled. It means that r dash is equal to r divided by 4. So r divided by 4, it is r1 by 4. So that will be exactly the answer. So this is how we do this. Okay, dear students, so if there is any other doubt, anything that you want to ask or say, please mention that in the comment section. Or if you are a member on the YouTube channel, there is a WhatsApp group also. You can ask doubt on that group also. Okay, dear students, so this is how we do this question. This is Professor Varun. Thanks for watching the video. All the best. Bye. Okay, dear student, let us see what is there in this question. The gravitational field strength at the surface of the Earth is 9.8 Newton per kg. The use of this value to calculate the weight of an object above the surface of the Earth is a paradigm shift in our understanding of gravity, an attempt to model gravitational field, an outcome from a peer review, an approximation used for the estimation purposes only. I think the answer will be D, because that seems to be the most suitable. Let me explain you. What is my understanding of this question? They are saying that the gravitational field strength at the surface, like in the formula, you have to use the radius of the Earth, which is like 6,400 kilometers to be very precise. So that value is used, and you would be getting the value 9.8. But what about a little above the surface? Like, let us say you are on a building which is like kind of 200 meters above the surface of the Earth, 100 meters above the surface of the Earth. So what do you think? Would you be using the 9.8 still? And or you should not be using it, because technically speaking, the gravity is not 9.8 when you start increasing your height. Like, for example, you go to the Mount Everest, so there will be some amount of the gravity which will be lesser than this, but definitely it will not be that very different. It can be approximated to be 9.8 very easily. So we can clearly say that if you want to find the weight of an object above the surface of the Earth, and you are still using 9.8, which is the gravity only at the surface of the Earth, clearly it is an approximation used for the estimation purposes only, that much should be the force with which the Earth will be pulling you towards the center of the Earth. So that could be the force. So clearly in this case the answer will be D. A, B, C do not make any sense. They are really vague. Like the peer review, it has nothing to do with it. An attempt to model gravitational field, it has nothing to do with the weight. Yes, it could be an attempt to model the gravitational field, but that is what is the work done by gravitational field strength itself. Why do you want to find weight? B is wrong. A, the paradigm shift in our understanding of gravity, not at all. So D is the correct answer. This is my explanation. Okay, dear students, thanks for watching the video. All the best. Bye. See you in the next video. Okay, so let us see what is there in this question. White light is incident on gas at very low pressure. The light passing through the gas is analyzed. What phenomena is being investigated here? So clearly this is the absorption spectrum, and we have done that in our topic when we were doing it. So let me explain you. This is a kind of capsule, you can call it. There is a gas contained in this, like let us say hydrogen. So white light is incident on it. Some of the colors will be absorbed here by the gas. So this is the white light, and it is coming here. So some of the colors have been absorbed by the gas. So the light that you are getting here is the light from which those colors or those frequencies are not present. Clear? So this creates a recognizable spectrum, which is called the absorption spectrum. It is so much recognizable that the hydrogen gas would be producing the same kind of spectrum wherever you go, whatever you do. So these kind of spectrums are usually used to identify the gases, identify gases in a gas chamber, or you want to say identify the gases on stars, because we would be learning that in option D of the astrophysics, that we use this phenomena of investigating the absorption spectrum of the light, the way it is done now. So we just find what is the gaseous chemical composition on the star. So absolutely the answer will be A, that is absorption spectrum. Okay, dear students, all the best. Bye, see you in the next video. Okay, student, let us see what is there in this question. A student measures the count rate of radioactive sample with time in a laboratory. The background count is 30 counts per second. So this is basically the disturbance. So whether the reaction is taking place or not, the device on which you are measuring the count rate, it is showing 30 count. So this is like all the values, they have been added with the 30. So the table is given. What is the time at which the student measure the counter to be 40? It means be very particular about this. Try to understand. 150 is the count rate. So actual number of disintegration is 120. 150 minus 30. Because 30 is the background count which was recorded just like that. So 90 minus 30 is 60. And here 45 minus 30 will be 15. So 15 is the number of disintegrations that you are looking forward to. 120 is the initial number of disintegrations. You can say that it started with this. And 60 is like the disintegration that was coming down. So we can say that there is a formula, n divided by n naught is equal to half raised to power t divided by t half. So the formula is not given in the book, as well as it is not given in the data booklet, but many of the solutions for paper 2 questions given by IB, they use this formula. So this formula is authenticated, no problem about that. And if you want to learn more about this, you have to subscribe to the YouTube channel, you have to join the YouTube channel, and then you can access the online course. There you can find the topic of count rate and you can see this. But till then, if you have not done, I would be doing it here. So n number, you want it to be 15. N naught, you started with 120. Time you want to find, and half-life is not given. But be very careful here. You started with 120 and now it is 60. It clearly shows that 20 is the half-life, isn't it? Because it was 20, now it is 60. So 20 is the half-life. So 20 second, it will be written like this. Now we want to solve this equation and we would be having our answer. So 15, when you divide this, you would be getting 8. 15 8s are 120. And so we can write this 1 by 8 as 1 by 2 raised to power 3. And this is written as 1 by 2 raised to power t divided by 20, which means that t divided by 20 should be equal to 3, and which only means that t is equal to 60 seconds. And that is why C will be the correct answer. And this is how we do this question. So I know that there is like this kind of question is very, very specific. Count rate, no book is talking about it. And the formula is not available in the data booklet also anywhere. But I have done couple of questions. They are already present on the YouTube channel. You have to just find. I believe if you would be writing count rate, Professor Varun, and you will search it on the YouTube or on the Google, you would be getting 4 or 5 such questions. And you can see all of those questions, how I have done. There are a couple of questions in paper 2 that I have done for this, and paper 1 also, in which IB had given graphs and others. So complete analysis has already been done and they are already available on the YouTube channel. So if you have problem with this, please try to search those questions on the YouTube channel. Just write count rate and my name, that is Professor Varun, and you would be finding those 4 or 5 videos. Okay, dear students, so this is how we do this question, and the answer for this question is C, that is 60 seconds. Thanks for watching the video. Please share the video with all your friends. Also join the YouTube channel. All the best. Bye. Okay, dear students, let us see what is there in this question. 3 statements about the binding energy are provided. Number 1, the binding energy is the energy required to completely separate the nucleons. Point number 2, the binding energy is equivalent in units of energy to the mass defect when the nucleus is formed from its nucleons. The binding energy is energy released when the nucleus is formed. Well, okay, let us first try to understand what is binding energy. So what is happening is, the basic definition of binding energy is, let us say these are all four nucleons, like two are proton and two are neutrons, let us say. So they are at infinite distance from each other, they do not interact with each other, so they have to come together to create a nucleus. So when they come together and a nucleus is created, some mass have to be given up by these nucleons. Obviously they have to cover up the individual repulsion which is taking place between two protons. They have to cover up that repulsive forces, so some energy has to be created. So what happens is, when they come together they lose some mass, so that delta m is called mass defect and a nucleus is created. So the first thing to be noted here is that the nucleus is having overall lesser mass, and these nucleons separately they have more mass. This mass defect is now converted into energy, the formula given by Einstein. So this energy, this mass is converted into energy, and this is known as the binding energy. So when a nucleus is created, clearly the energy will be released. So energy is released here. Okay, so you can say energy is given up, released. Why released? Because mass has vanished. Now these are having more mass, this is having lesser mass. So where is that mass going? Mass is converted into energy. This is the part number one. So point number three is absolutely correct. Binding energy is energy released when a nucleus is formed from its nucleons. There is no doubt about it. And point number two, the binding energy is equivalent to the mass defect. Even that is correct. Binding energy is equal to delta mc square. So even this is not a problem when a nucleus is formed from its nucleons. So this is also correct. So 2 is correct and 3 is correct. Absolutely. Let us go for point number 1. The binding energy is the energy required to completely separate the nucleons. Now you want to break up the nucleus. Now the same amount of energy has to be given back. Like you give that energy back. So all these nucleons, they will separate themselves. Okay, and the energy, like the mass was converted into energy, so this energy is now again going to create mass for all of the nucleons, and the same amount of mass will be given back to the nucleons, and they would be returned back into the different particles. Is it clear? Like this. So this nucleus is now broken down, so energy has to be given to it. So even the point number 1 is correct. It is just the reverse of that. You can just call it exoergic. Exoergic nuclear reactions are the reactions in which energy is released. Endoergic are the nuclear reactions in which energy is given. So they are basically reverse of each other, nothing more. Isn't it? Endoergic and exoergic. At this point, the students, those who have chemistry as a subject, please try to understand endothermic and exothermic, they are chemical reactions. When you talk about the nuclear reactions, we do not use those terms. We use exoergic and endoergic. Okay, dear students, so this is Professor Woon. Thanks for watching the video. Please join the YouTube channel if you want to access the paper 2 questions now, and if you want to access the online course. Okay, dear students, all the best. Bye. Okay, dear student, let us see what is there in this question. The following reaction is proposed for collision of proton and a neutron. So proton and neutron coming together, they create a proton and a pi meson. So the neutral pion consists of up quark and anti-up quark. So this is basically meson. Which conservation law does this equation violate? Very good. Let us see. So I believe the baryon number is the correct answer for this question, because we can just clearly see here. So the baryon number for the proton is 1. For the neutron, it is 1. So it is 2 on the left hand side of the reaction. And once the reaction has taken place, the baryon number for the proton is 1. And for the meson, the baryon number comes out to be equal to 0. So we know that the baryon number for meson is 0. For up quark, it will be 1 by 3. For anti-up, it will be negative 1 by 3. That is why when they come together and they create a meson, the baryon number becomes 0. So clearly the baryon number is the one which is violated. Let us verify if other laws are violated here or not. Proton is having +1 charge, neutron is 0. +1, neutron pion is also 0. So charge is not violated. Lepton number here is 0. Here also lepton number is 0. Even this is not violated. Strangeness is 0 on both of the sides. Even that is not violated. So only A is the correct answer for this question. So this is how we do this question, dear students. This is Professor Boone. Thanks for watching the video. Please join the YouTube channel for better services. All the best. Bye. Okay, dear student, let us see what is there in this question. Wind generator X has a maximum power output of Px for a particular wind speed. So let us first talk about the power which will be produced by a windmill. What is the formula for that? Let us get introduced to that. So the power is given by 1 by 2 rho a v cube. Yes, this is the formula for the power for the wind turbine. 1 by 2 rho a v cube. And it says that in the case of X turbine, half rho A is the area of X, which could be different. Yeah, the radius, there is a change there. And the velocity can be taken to be same for the wind. For the same wind speed, yes, the wind generator Y has a maximum power output of Py, and that is half rho AY V cube. So this is the maximum power that will be produced by the wind turbine Y. The blade radius of Y is 3 times. So the radius of Y is 3 times the radius of X. So clearly the area will be directly proportional to R square. So I can say that this area will be 9 times the area of X. So this AY can be taken as 9 times AX. Am I correct? Pi R square. And so the radius is 3 times. Yes, AY will be 9 times AX. So that is clear. And V cube is here. So this is definitely 9 times. Okay. But we will not be jumping to the conclusion as of now. Let's see. The blade radius is 3 times. Y is twice as efficient as X. Okay. So there is an efficiency also. So let us say the efficiency is given by eta. So it will be multiplied by eta, like 0.3, 0.4, whatever it is, we will multiply here. And Y is twice efficient, so that will be multiplied by 2. So 9 is one factor, 2 is another. So clearly 18 will be the answer. Let's see. Py divided by Px, we are just now dividing Py divided by Px. So Py is half rho. Ay can be written as 9 times Ax. V cube twice efficiency. So that will be half density Ax V cube and eta. So eta is getting cancelled, V cube is getting cancelled, all the constant terms get cancelled, and you are getting 18 here. So clearly the answer will be D in this question. This is how we do this question. This is a formula which is very, very important in the case of windmills, and it's a highly popular formula for IB. IB is asking many questions from the windmill, and this question kind of repeat telecast, I can say, in our examination. So it will be very good if you remember it. Okay, dear students, this is Professor Boone. Thanks for watching the video. Please join the YouTube channel if you want to access the online course and the paper 2 solutions. All the best. Bye. Okay, dear student, let us see what is there in this question. What is not correct about photovoltaic cell? It has an output power that is related to the surface area of a cell. Well, that is exactly correct. More is the area covered, more power will be produced by the solar cell, no doubt about that. It generates an alternating current. This is wrong, because solar cell, photovoltaic cell, is always producing DC current. Okay, that has to be converted into alternating current later. It absorbs energy over a range of photon frequencies. Absolutely correct, because the energy which is coming, definitely it will be in the range of infrared. It will be in the range of light waves, but that doesn't mean that the color of the light will be this and all that. So it could be anything, but the solar light should come and fall on the cell. So there is a range of photon frequencies that are valid. It can be used to store energy in the secondary cell. Absolutely correct. Like if there is a solar cell there and you are connecting it with the secondary cell, so it can create DC output, and DC output is now DC input into the secondary cell, and thereby it can recharge the secondary cell. We all know that secondary cell can be recharged only with the help of DC current, not with the help of AC current. So this is one of the primary uses of solar cell, that we use solar cell to store energy in our battery. Okay, dear students, so this is enough for the explanation for this simple question, I believe. This is Professor Varun. Thanks for watching the video. Bye. Okay, dear students, let us see what is there in this question. A planet has an albedo of zero point 0.3. The simplified energy balance for the planet is shown. What is the intensity radiated by the surface of a planet? Okay, so let us read this thing. See, the incoming intensity is taken to be 100. Zero point 0.3 is the albedo. It means that the 30 watt per meter square is the energy which is reflected back by the clouds, by the surface of the planet, and whatever. 30% is gone there itself. You are left with 70 watt. So 70 watt per meter square is the energy which is absorbed by Earth. Obviously, if the temperature has to remain constant, so this energy has to be radiated back, so this will be given here. So in the first instant it feels like 60 is going, like it is reflected back from the atmosphere to the earth. So the answer here should be 10 watt per meter square. So that is what we usually think of, but as we can clearly see, 10 is not an option here, so definitely that is wrong. And why is that wrong? The another reason is that earth cannot, like, what earth will do with this kind of an energy, because it is like the radiated energy has to be equal to the incoming intensity, otherwise the temperature of the earth cannot be constant. It will start increasing. It will start increasing. So the first condition is that 100 watt per meter square is coming to the earth, so 100 will be going out. That is for sure. We just assume it. That is what is within our syllabus. So 100 is coming in, 30 goes here, so clearly 70 is given out here. So we will assume that 70 watt per meter square is radiated like this. 30 watt is returned just by the reflection. So 70 is going out. It means 70 plus 60. It means 130 watt per meter square is the energy which was actually given up by Earth. Ironic, isn't it? But yes, this is what happens. Why I am sure about it? Because there is one more question that IB has asked, and I have already solved that. If you have watched that video from the previous year questions, they were using the same concept in that question. So what was happening? 130 watt is radiated by Earth. From where is that energy coming? Because Earth is actually absorbing only 70, but Earth is emitting 130. From where is that energy coming? Actually, the 60 watt per meter square energy which was trapped in the atmosphere, it is again going to the surface, and it is again mixed with this 70. So it's basically 70 plus 60 that is coming here. So 70 plus 60 is 130, and out of this 130, 70 is emitted back to the space, and 60 watt per meter square energy is trapped inside the atmosphere, which keeps on moving like this, here. So it is neither going out nor it is coming from outside. I don't know from where this energy is coming, but this energy has come up from somewhere, and this is trapped inside this. So earth is like, you can say that earth is warm, and like the temperature of the earth's surface is comparatively much more than what it is for the Venus, what it is for the other planets. So there is a possibility that this energy is now trapped because of various reasons. So this is how we do this question. So the answer for us is 130, and clearly the answer is the option D. So D will be the correct option, and this is the right explanation. What I did in these questions, try to understand the energy which is coming to the surface of the earth, that should be going away from the surface of the earth. That is the limiting condition, the final condition for us. So 30 is here, so 70 will be here, 60 is going this side. It clearly means that 130 should be the energy that is radiated. Now, one more point I would like to clarify here. Whenever they say energy radiated, they are actually talking about only and only emission. They are not considering reflection in their calculation. This is emission. Now, what is the difference between emission and radiation? Radiation is happening instantly, but emission is taking time. First, absorption will take place. So definitely Earth's temperature is going to increase for some time. Like for example, we take the case of desert. In day, the desert's temperature is very very high, but at night it is emitting all of the energies, and that is why nights are colder in desert area. So this is what is the exact explanation for this question. Okay dear student, thanks for watching. This is Professor Varun. Please join the YouTube channel if you want to access the complete online course as well as the paper 2 solutions. All the best. Bye. Okay, dear student, let us see what is there in this question. A mass oscillating in simple harmonic motion on the end of a spring has an amplitude of x naught and a total energy of AT. The mass of the spring is now doubled, mass on the spring, not off the spring, made to oscillate with the same amplitude, that is x naught. What is the total energy of the oscillating system after the change? Okay, so here, my dear students, there is a very big catch. I will tell you what. Try to listen to this now. So the formula for the potential energy, elastic potential energy, which is to be used in the case of spring mass system, is given by half k amplitude square. So x naught square is the amplitude. So this is the formula for the max energy. Now, if we use this formula where k is a spring constant and we are not messing up with the spring, so the k remains constant, the mass is 2m, but the amplitude remains the same, that is x naught. Clearly, half k, which is constant, x naught is also constant, so energy contained in the spring does not change. So clearly our answer is A in this question, half k x naught square. Now I tell you what other students would have done in this question, and why I say that 99% of the students would be going with, I think, C option here. But let me tell you why. So majority of the students want to use the data booklet, and the formula given in the data booklet is half m omega square x naught square. This is the formula which is given in the data booklet, and you would be opening the data booklet at that time and you will see that okay, mass is there, mass is doubled, clearly the energy is doubled, and hence the answer is C. And there you are, the answer is wrong. A is the correct answer for this. My dear students, at this point, data booklet is really deceiving you people, isn't it? In my private lectures, I have told like 1,000 times to my students, this formula is not supposed to be used ever. Like, this formula is given in the data booklet, but I believe this is one of those formulas which are highly deceiving, and this formula is not required. I tell you why is this formula giving you a different answer. You see, definitely mass m is there, and if you are doubling the mass, it is getting multiplied by 2, but you forget that omega is also sitting here as a variable. Omega is not constant. What is omega in this? Omega is equal to k by m square root. This is how we define the natural frequency. Okay, this is how the natural frequency, omega is basically the natural frequency of the system. What is natural frequency? You just disturb it and leave it. The frequency chosen by the system by itself is the natural frequency. So this omega is natural frequency. So this natural frequency is in itself dependent on the mass m. From this equation, I can say only k is constant, m is variable, and omega is also a variable. So it means that it was half, mass is doubled, but what is happening to omega? It is omega square. So omega square is equal to k by m. Clearly, when the mass is doubled, your omega square is getting divided by 2. So your new omega is omega square divided by 2, and thereby 2 and 2 are getting cancelled, and this is what students have not considered. They think that omega, there is no change in omega, there will be no difference in omega, but you are wrong, because your natural frequency is dependent on this. What is the time period for a spring pendulum? 2 pi root of m by k. Clearly the time period is dependent on the mass m, and from there also you can say that omega is dependent. So omega is equal to 2 pi by t, and so by using this formula you can clearly see that it is coming out to be k by m square root. So K is constant, but other two variables are not constant. So this formula given in the data booklet is highly deceptive, and you must not be using this formula. Well, as of uh, as per my knowledge, as of now, I believe this formula should not be used in any of the cases. It's kind of redundant. You please refrain from using these kind of formulas. But but in coming time, if I be create some question where this formula will be of some use, I don't guarantee you that. But as of now, this formula is not to be used in any of the questions. This formula, on contrary, is world's most famous and most popular, most effective formula when it comes to energy in simple harmonic motion. You need not to know any other formula, by the way. Okay, dear students. So this is Professor Varun. Please share the video with all your friends and join the YouTube channel if you want to learn even more deeper concepts, because I would be providing you with the online course where I'm already talking about these kind of concepts, and I would be providing you with all of the descriptions for paper 2 questions. You need to join the YouTube channel. Okay, dear students, all the best. Bye. Okay, dear student, let us see what is there in this question. Monochromatic light is incident on a single slit to form a diffraction pattern on a screen. The width of the single slit is then halved. What are the changes in the width of the central maxima and the change in the maximum intensity? So first of all, the diffraction is taking place, and there is this one slit. This is the screen in front of you, and so this kind of diffraction pattern will be there. This is kind of central maxima. Okay, now what is happening, this length is reduced. So what is this fringe width? Like, we can just call it spacing or something. Yeah, so this gap is given by lambda capital D divided by B, where B is the width of the slit. Yes, that is B. And capital D is the distance between the slit and the screen. Lambda is the wavelength that you are using. So this is half of this distance. Like, it will be this distance. So this distance is given by lambda capital D divided by B. So you multiply by 2, you get the actual fringe width, which is double of this. So if you're halving the the slit width, definitely you are multiplying this equation by 2. So the width of the central maxima is double, so it is increasing. And what is happening to the maximum intensity? Although we do not have any formula that is used, that can be used to substantiate the argument for the intensity, but we can clearly see that if the slit thickness is reduced here, so there is less amount of light rays which are going to coincide, which are going to superpose. So clearly the intensity is going to reduce because there is lesser light which is now merging there. So definitely the intensity is decreasing, and hence the answer for this question is C. There is no doubt about that. So these are the two things that we are going to use. It is monochromatic light, means wavelength is lambda. It is given like there is only one wavelength, and it is a diffraction pattern, so we would be using the formula lambda D by B. So this is how we do this question. This is Professor Varun. Thanks for watching. Please share the video with all your friends. All the best. Bye. See you in the next video. Okay, dear student, let us see what is there in this question. Two spheres have the same positive charge. A point M is midway between the two spheres. Along the line joining the spheres, what is true about the electric field and the electric potential at M? So when they write electric field, you have to read it as electric field strength. So they are actually talking about E, and when they talk about electric potential, they're talking about V. Okay, so we have to comment on the midpoint between the two charges. So clearly the electric field will be zero. Why? Because this positive charge, this positive charge will be creating an electric field which will be moving away from it at the point M, like this. And a similar charge, or the same amount of charge, because the charge is same, the distances are the same, so even the magnitude is same, but that is created in the opposite direction, thereby cancelling these two, and so the net is zero. What is the formula for the electric field strength? That is K capital Q divided by R square. So K is constant in both of the cases. Q is constant in both of the cases, and R is from the center to this, and that is also same because it is a midpoint. Now, what about the potential now? So potential is bit dicey, but now we have done so many questions from the paper 2 in regards to electric potential by using the similar concept. We have done so many questions now, so you should be good with this. But anyways, let me explain you what is happening. So what happens here is, let us say this is charge 1 and this is charge 2. This is the distance. So midway at any point, you would be first finding the potential because of 1, and then you find the potential because of 2, and then you add them, and then you find the total potential. This is what is the physics in this. But what is happening is that the formula for potential is kq divided by r. So lesser is the r, the distance between the center of the sphere and the point M. Lesser is the distance, more becomes the potential. So much so that if this r becomes tending to 0, the potential will become infinite. But that is definitely not the case. R cannot be 0. At the end of the day, this r will be equal to the radius r, we can say, because we want to talk only about the surfaces of the spheres, like this. So this potential will be maximum here at the surface, and after that the potential will be reducing, because overall the variation is somewhat like this, isn't it? If you are talking about one single sphere or one single charge, so the potential here is having some maximum value, and at the midpoint, so v1 is there, v2 is there, but the values are lesser, so much so that v1 plus v2 are still lesser. So that is still positive, but it is the minimum value, like this. And here again the value will become very high, so it will go somewhat like this. So this value is again higher, this value is again higher, and within the two spheres the value of the potential will be constant. So there was some paper 2 question, they have taken this question from that, like it's clearly similar to that question, I would say, like kind of same. So inside of a sphere the potential is not changing, it is always constant, because inside a sphere the potential is equal to the potential which is at the surface. So this will not change, this will not change, it will be constant, and there will be a bowl shape there and having a minimum positive value at this point. So this is the point where v is equal to v1 plus v2 is minimum, and electric field is 0. So E net is equal to 0, which means that E1 is equal to E2. So this question is very important from the point of view of paper 2 also. So this question becomes highly quite important for us. So you must remember these things. Okay, dear students. So accordingly, the electric field will be 0 and it will be minimum positive value. So A will be the correct answer. No doubt about that. Okay, dear students. So this is Professor Varun. Thanks for watching the video. Please share the video with all your friends. Also, join the YouTube channel if you want to access the similar kind of explanation for all of the topics as per the online course is concerned, and also for all of the paper 2 questions. Yes, you can join the YouTube channel now and access both of these. All the best. Bye. Okay, dear student, let us see what is there in this question. The mass of Mars is about 10 times that of Moon. The radius of Mars is about twice that of Moon. What is the escape speed from Mars divided by escape speed from Moon? Okay, so first of all, we must know that the formula for the escape speed is twice of gm divided by capital R square root, and R is the radius of the planet, radius of the astronomical object, whatever you're talking about. So this is the formula that we have for the escape velocity. Now it means that escape velocity for the moon, it will be 2g, and g is a constant. So the Mars mass is 10 times that of moon, so I'm just calling it m, and the radius of the Mars is twice, so we will call, for the moon we will take it as r. It means that the escape speed for Mars be given by mass is 10 times that of the moon, yes, and the radius is double, like this. So there is a factor of 5 there, yes. So if we divide this equation by this equation, you would be getting square root 5. So answer will be A, no doubt about that. We can do it. So escape speed of Mars divided by escape speed of Moon is equal to, I will not be writing the complete equation, okay? You can just divide these two equations by yourself, and the answer for our question is A. So this is how we do this question. Thanks for watching the video. This is Professor Varun. Please share the video with all of your friends. All the best. Bye. Okay, let's see what is there in this question. A single loop of wire of resistance 10 ohm has its plane perpendicular to the changing magnetic field. The graph shows the variation with time of the magnetic flux through the loop wire. So the flux is definitely directly given, like it is Weber, and the unit here is second. What is the maximum current in the loop? Okay, so according to the question, there is only one loop. It means like that n is equal to 1. There is only one loop, and magnetic field is passing through it like this. Yes. So there is a certain value of a flux and the graph is given because it is having a variable magnetic field every time. So as a matter of fact, or just for the remembrance, I can tell you flux formula is given by BA cos theta, where B is the magnetic flux density. You can call it magnetic field strength also. And A is the area which is perpendicular to the magnetic field, and theta is the angle between the two variables, that is area and the magnetic field. So whenever there is a variation in the flux with respect to time, EMF is generated. So EMF is given by delta phi by delta t. Now flux can vary, point number one, with the help of magnetic field, which is actually the case here. Point number two, with the help of the area of the loop, which becomes the case of motional EMF. And theta, which is kind of orientation, which is exactly the case with the electric generators. Okay, having said that, we are not going to move into the 100% details now. Okay, so the graph given is flux and time. So flux and the time graph is given. We want to find the maximum current in the loop. So the current will be a variable and we have to find the maximum value. So at this point, the flux is variable for the first 2 seconds, and from 2 seconds to 5 seconds, flux is not a variable. So when flux is not a variable, EMF is not produced. So in this case, EMF is not produced, but here EMF is produced. Here EMF is produced in both of the cases. But here we can clearly see that the slope is more. So d phi by dt or delta phi by delta t, which is actually the slope of phi t curve. So the slope of phi t curve is more in this case and lesser in this. The slope is lesser. So the EMF produced here will be, we have to find the tangent theta here, okay? So that will be 40 Weber divided by 20. So it will be 40 divided by 2, that is 20. So this is d phi by dt, so that is the EMF. So EMF generated in this case initially is 20 volt. And the resistance given is 10. Clearly the current produced will be 20 divided by 10, that is 2 amperes or 2 amps. So the answer will be B. But let us first verify from the other side also, because like it is clearly, we can clearly judge it from the diagram that this slope is more than this. Definitely more EMF will be generated in first 2 seconds, and that is why the answer will be 2. But let us go for this EMF now. Yeah, so the answer for this is let us see, 40 divided by 1 2 3 4. So it is 40 divided by 4 seconds, so that is 10 volt. Clearly the EMF is 10, and so the current produced now is 1 ampere. So our answer is 2 ampere for this question. So this is how we do this question, dear students. This is Professor Varun. Thanks for joining. All the best. Bye. Okay, dear student, let us see what is there in this question. An AC generator produces root mean square voltage V. What is the peak output voltage when the frequency is doubled? Okay, so just in the other question, I was telling you that the flux is given by BA cos theta, and whenever there is a change in the flux, EMF is generated. So there are three ways in which flux can be changed. Number one, you can change the magnetic field. Number two, you can change the area, which becomes the motional EMF. And number three, when you change the orientation of the coil, which is exactly the case with AC generators, isn't it? Now, if you are varying this theta, what happens is this is big. You can have n number of turns here, and this is cos omega t. This is phi. So let me just differentiate it very quickly, and I can give you the derivation for that also, isn't it? So when you differentiate it, it becomes negative nba omega sine omega t, because it is omega, because it is omega t, like theta, which is dependent on time. That is why I have written as omega t. When you differentiate it, you become, this becomes this. Now EMF is defined as negative d phi by dt, so thereby it is positive. So this is our final answer. This is the EMF that is generated in the case of AC generators, because it is alternative current, isn't it? Like sine omega t is there. So we can simplify it and we can write it as E is equal to E naught sine omega t. This is E naught and this value is E. So E is equal to E naught sine omega t. Now this question is talking about peak voltages. So let us have another formula here. Let me explain you one more concept. Root mean square voltage. Now the peak voltage is the amplitude in the equation. So the RMS value is equal to the peak divided by square root of 2 whenever the variation is a sinusoidal. So whether it is current, whether it is voltage, whether it is anything, if the variation is sinusoidal, then the RMS value will be given by peak value divided by square root of 2. So in the case number 1, initially the peak value is equal to root 2 times V, because V is the RMS value that is given here. So initially this was the peak value and this is the value that we can find from the given data. So peak value will be referring to NBA omega. NBA omega. But now omega is doubled, the frequency is doubled, which means that now the peak voltage is doubled. So in this case, like the new case, I just call it V naught dash, that will be equal to, it will be double of this. So it will be 2 square root 2 V. So it will be double of whatever it was, because now the frequency is doubled. So clearly the peak value of the EMF is directly proportional to the frequency. So if the frequency is doubled, the peak value is doubled, and hence our answer for this question is D. So this is the explanation for this question. This is how we do this. Okay, dear students, so thanks for watching the video. Please join the YouTube channel if you want to have this kind of explanation for all the paper 2 questions. And also you can access the online course then. So joining the YouTube channel is a very good decision, I would say. Please join the YouTube channel. All the best. Bye. Okay, dear student, let's see what is there in this question. Step-up transformers are used in distribution of electrical energy to reduce the danger of electric shocks to humans? No. Step-up transformer is anyways going to increase the voltage. So the voltage is kind of 100,000 volt now. So it is actually increasing the danger. Decrease the potential difference between the ends of the long distance transmission line. It does not decrease it. In fact, it increases it. I just told you 100,000 volt. Allow direct current appliances to work in the domestic application? Not at all. Decrease the electric current in the long distance transmission lines is absolutely correct answer. Please try to understand what is actually happening in this case. So whenever there is this powerhouse, like I don't know whether the powerhouses are looking like this in your country or not, but this is how we draw it, isn't it? So this is giving us the power output now. So what we do, we use a transformer here, and then this electric wire lines, they are going for, like, like they are going over a very long distances, and after that they reach very near to your home, and then they goes to a transformer. Then this transformer is acting like step down transformer, and then only the electricity is fed to our houses, isn't it? So this is the step up transformer and this is step down transformer. Now what is happening? Why are we doing this? First of all, so when the power is generated, the voltage is very less and current is higher, like power P is transformed uh, transferred from the power plant to your house. So power P can be assumed to be constant if I assume 100% efficiency for the transformer and others, isn't it? So this power is to be transformed, okay, transferred. So the power input to the transformer can be written as P is equal to V1 I1, P is equal to VI. So that is V1 I1. And the step up transformer is creating V2 voltage. So this power will be equal to V2 I2. I'm just assuming 100% efficiency for the transformer. So this is V1 I1 is the input and V2 I2 is the output. What happens is if the voltage is becoming 1000 times, the current becomes 1000 times lesser. It means that while the current is passing uh, over the wire for hundreds of kilometers for long distances, then I square R losses will become too much because the resistance of the wire will be very heavy, and so the power losses will be too much, and we do not afford that much. So the only option that you have is to reduce the current which is passing through the wire. How can you reduce it? By increasing the voltage, because power is constant. So V2 has to be multiplied by 1000, thereby dividing current with 1000. So the current becomes reduced by 1000 times, thereby reducing the power by 10 raised to power 6. You getting my point? So the power is kind of reduced by, I don't know how much, by 10 raised to power 6 times, isn't it? This is the reason that we are using the step up transformer to decrease the electric current in the long distance transmission lines, so that the power losses, which is I square R losses, during the transmission, they are reduced. So this is the reason, hence the answer is D. Okay, dear students, so this is Professor Varun. Thanks for watching the video. Please join the YouTube channel for accessing the paper 2 solutions and online courses. All the best. Bye. Okay, dear students, let us see what is there in this question. Two capacitors C1, C2 are connected in series to a cell. The capacitance of C1 is 4 times that of C2. So this we can assume as C, and this will be assumed as 4C. The charge stored on C1 is Q1 and charge stored on C2 is given by Q2. What is the ratio of Q1 and Q2? Okay, so first of all, these two capacitors are in series combination. And what is the condition for the series combination? It's not that the two capacitors should be connected in series. This is what I'm asking. Like, what is the actual definition for series combination? The actual definition for series combination is when the capacitors are having same charge on them, then only we call that the two capacitors are in series. So clearly these two capacitors are in series, so charges will be same, and hence Q1 is equal to Q2. So Q1 by Q2 is equal to 1, and clearly the answer is C. There's no doubt in this. But let me have this opportunity to explain you what is actually happening in series combination, why the charges are the same, and what is happening in the parallel. Please listen to this. Okay, let us say that Q charge is coming from the battery. Q positive charge is coming from the battery. So this plate will become positive, and here the positive Q is there. Okay, and I will say that this is having positive Q charge and this is also having positive Q charge. Ironically, it looks like that the battery has given only single Q, but both of the capacitors are having Q charge each. So isn't it like a wrong understanding that the charge which is coming from the battery is Q, but this is also having Q and this capacitor is also having Q? How can you explain this phenomena? Let me tell you this thing. Now this is the charge Q which is coming. So this plate becomes positive Q, and let us say the negative charge is also going. So this is also becoming negatively charged, isn't it? What about these two plates which are actually not connected with the circuit, isn't it? There is air which is an insulator in between these two plates. So technically this charge is not jumping. So this charge is not traveling here. So induction is taking place. And this becoming negative charge. Same charge is induced on this. Clearly the same charge is induced on this plate also. So that is why I can say that C2 is also having a charge Q and C1 is also having a charge Q. Because overall the battery is releasing charge Q, All the other capacitors are getting charged because of induction. That is why they are having the same charge. And the ironic thought that the charge released by the battery withdrawn from the battery is q, but both of the capacitors are having a charge q. So it is not that both of the charges are like 2q charge should be coming from the battery. It is not like that. Okay, so this is what is the series combination. And now what is happening in parallel, let me give you the definition for that, and then we can close the video, no problem. So in parallel combination, what is the definition? The definition is that the combination in which the potential difference across the two capacitors is the same. So if the potential difference across the two capacitors become equal to each other, we call them parallel combination. Clearly this voltage will be V2, this voltage will be V2. So Q is equal to CV. When capacitances are not equal, Q is equal. How can V be equal? If capacitance is 4 times, then the voltage across them will become 1/4. So this will be V by 4. This will be V. It's somewhat like that. So this is the difference between the series and parallel. Okay, dear students. So this is all about series and parallel combination. Thanks for watching the video. This is Professor Varun. Please join the YouTube channel if you want to know more concepts. All the best. Bye. Okay, dear student, let's see what is there in this question. A charged 200 microfarad capacitor is placed in series with a 10 kilo ohm resistor. At time t is equal to 0, the current is I. So this is about the discharging of a capacitor. Let us say this is positive and this is negative end. So the current will start flowing. Clearly, it is the case of discharging of a capacitor. What is the time taken for the current in the resistor to become this much? Okay. So first of all, this question is about the discharging of a capacitor. So in this case, we know that Q is given by Q naught, e raised to power negative t by tau. Current is also given by the same thing, T by tau, and the voltage across the capacitor is also having the same variation. But now we want to talk about the current. Okay, so we would be using this, and the peak value would be happening at t is equal to 0. So at t is equal to 0, the current is I. It means that I is the peak value, which I have taken as I naught. So this peak value, I would be using this equation now. Let me substitute this value here. It means that the peak value divided by E cube should be the new current, and this is I naught, this divided by tau. Peak value and peak value gets cancelled out. Clearly, t by tau will be equal to 3, and so the time taken will be 3 times time constant. The time constant value is not given in the question, so we will find it. Time constant is given by the product of resistance and the capacitor. It is 1000 into 10 raised to power 10 into 10 power 3 and 210 raised to power negative 6 because it is micro. So this and this is getting cancelled out, negative 3. This will cancel out with 3 zeros. So the time constant is coming out to be 2 seconds. Clearly, we will multiply it with 3 and the answer will come out to be equal to 6 a second. So this is how we do this question, dear student. So this is the case of discharging of a capacitor. Mind it, charging of a capacitor is not in our syllabus, but the graphs of that, they are given in the book, but the formulas are not given. So I am not discussing those formulas in any of my video. But anyways, as per the discharging of a capacitor is concerned, these are the 3 formulas that you have to remember. Quite simple. Plug in the value, get the answer. This is completely exponential curve. The graphs are like this, and it does have a concept of half-life. Okay. Okay, I will not be confusing you people here. You people can read about this, and if there will be some question about half-life, I will tell you. Okay, dear students, so this is Professor Varun. Thanks for watching the video. Please join the YouTube channel if you want to learn more such concepts. All the best. Bye. Okay, dear student, let us see what is there in this question. Light of frequency f is incident on a metallic surface of work function W. Photoelectrons with a maximum kinetic energy Emax are emitted. The frequency of incident light is now changed to 2f. What is true about the maximum kinetic energy and the work function? So one thing is very clear in this question. You see, work function is the property of the matter, of the material that you are using, like the material, the photosensitive material that you are using, like zinc or something. So it has nothing to do with the light which is falling on the material, isn't it? So work function is not going to change because it is the function of the material that you are using. So work function is definitely unchanged. Now, the light which is falling, it is 2f. Now, Einstein has said that the energy of a photon is used at two places. So, it will be used for the work function, and rest of the energy will be resulting as the maximum kinetic energy for the electrons. So, this is the Einstein's photoelectric equation. So, this is one case, and I'm just calling it K. And in the second case, when 2 is multiplied with the frequency, so now the energy of photon is doubled. Work function remains the same, but now the kinetic energy is K dash. Definitely now the kinetic energy is more because the frequency is more, photon is having more energy. So definitely it is going to be more. So answer will be C. But there is a problem, greater than 2 Emax. Anyways, answer is C, no doubt about that. But how can you explain that it is greater than 2 Emax? That is a bit dicey here. Let us see. So what we do here is we are going to play with the equation now. How? This HF is written as HF plus HF, and that is W plus K dash. Let us take W to the other side also. So that will become minus W is equal to K. So HF minus W can be written as K. So it will be HF plus K is equal to K dash. Now, still we are not able to prove it that it will be greater than this. So we have to substitute the HF also. So now I can again say that HF is equal to W plus K. I again substitute this. So that will become W plus K is equal to K dash. So it will become W plus 2K is equal to K dash. Clearly, by using this equation, we can say that yes, now in the second case, the final maximum kinetic energy will be more than the double of what it was earlier. Hence, the answer for us will be C. So this is how we explain this question. Thanks for watching the video. This is Professor Varun. Please join the YouTube channel for learning more such concepts. All the best. Bye. Okay, student, let us see what is there in this question now. What is the variation of nuclear density rho with the nucleon number A? Okay, so if you have this question as a doubt, let me explain you the background theory for that first of all. But overall, the answer is B. Why? Because the density is independent of the mass number and it is constant for all of the nuclei. But let us see why I'm saying that. See, the density of anything, whatever you want to talk, that will be equal to the total mass contained divided by the volume. And we are going to see this now. So let us say we talk about a nucleus. So the nucleus is having some mass number. So mass number means like 4 by 3 pi r cube. This will be directly proportional to the mass number A. From here, we can clearly say that the radius is directly proportional to 1 by 3. From there, we create a formula for ourselves. R is equal to R naught, A raised to power 1 by 3, where R naught is given by 1.2 Fermi meter, and Fermi stands for 10 raised to power negative 15 meters. So this is the R naught here. So R naught is a constant, and this is the radius of a nucleus. So this is the formula that we use to estimate the radius of the nucleus of various nucleus as per their mass number is concerned. Okay, now coming back to this, let us say there is a nucleus with mass number A. So what is the total mass? We can say that the mass of a neutron and mass of proton is approximately equal to 1 AMU. I'm just taking it as M. M multiplied by A, the total number of nucleons which are present there. Nucleon means the total number of protons and neutrons. So that is multiplied here. This will be divided by the volume, which is 4 by 3 pi r cube. Let us say r is the radius for that very nuclei. So r is equal to this. So this value we are going to use it here. So it will come out to be ma divided by 4 by 3 pi. This r cube can be written as r naught cube into a. So that is not a problem. I believe you can very well substitute that value there. A and A gets cancelled out. You see, what is this M? M is the mass of proton or the neutron. 4 by 3 pi is constant. R naught is also having a constant value, that is 1.2 Fermi meter. It means that the density of the nucleus is equal to some constant value, which I'm not writing here. I'm not finding it here. The only thing is that the density of all of the nuclei will be same. It does not change. It remains the same. Hence, the answer will be B. So this is how we do this. This is the explanation for this question. Okay, dear students, so thanks for watching the video. This is Professor Varun. Please join the YouTube channel if you want to learn more concepts. All the best. Bye. Okay, dear student, let us see what is there in this question. The uncertainty in the energy required for the pair production is given as 3 mega electron volt. What is the uncertainty in the lifetime of a pair? Okay, fine. So we know that the uncertainty principle given by Heisenberg can be written in two ways. The first is the uncertainty in the position and the uncertainty in momentum. That will be greater than h by 4 pi. Similarly, the same thing can be extended into this energy and the life of that particle, so that will be given by h by 4 pi. From this we are going to understand like how to find this. Let us see. So energy is 3 mega electron volt. So we are only and only interested in the order here. So we are only interested in raised to the powers. So 3 into 10 raised to power 6 is mega. Electron volt can be converted into joule by using this into delta T, and this is coming out to be 6.636 into 10 raised to power negative 34 divided by 4 pi. By the way, we can directly say that we can find the total number of zeros there and we can click the answer here. But I think that we have to use the calculator and we should be concerned with the value, the numeric value also that we are getting, because it is a possibility that there will be some one or two zeros, they will be creating problem. But when we see the options here, there is a very big gap in the powers. So clearly we can find the answer like that also. Let us see. So I am interested in this raised to the power. So 10 raised to the power negative 24. This when goes to the other side, it will be positive 19. 6 goes to the denominator, it will be negative 6. So it is going to be negative 40 and this is 19. So clearly the answer is coming out to be nearly 21. Do you see that? 21. Now that is the problem. This is what I was telling. So let us go for complete mathematical calculation. So 6.636 10 raised to power negative 34 divided by 4 pi divided by 3 into 10 raised to power 6, 1.6 into 10 to the power negative 19. So this and this we can get rid of this. So that is okay. Okay, let me use the calculator. I'm sorry for that. I'm getting confused there. Okay, so the value is 6.636 divided by 4 divided by pi divided by 3 divided by 1.6. Yes, so I'm getting 0.11 into 10 raised to power negative 34 plus 19 negative 6. So that is negative 21. Yes. So this is delta T, which is greater than or equal to this. So we are not interested in this now. So what will happen? Because whenever we want to find the order of a value, we got to have this decimal can be placed only after one digit, one non-zero digit. So this will come out to be 1.1 into 10 raised to power negative 22, if I'm able to explain myself, isn't it? So the order will be given as 10 raised to power negative 22, hence the answer will be D. If the option was given as 10 raised to power negative 21, even then the answer will be D. And because there is this concept, possibility is that you would be going with 10 raised to power negative 21 by mistake, but that will be wrong. 10 raised to power 22 will be the correct answer. Okay, dear students, so this is the explanation for this, and be very careful about this. You have to calculate it properly. You cannot calculate only and only the powers to 10. So because this concept can be there, which will be providing you with the wrong answer. Possibility is there. Okay, dear student, thanks for watching the video. This is Professor Varun. Okay, so let's see what is there in this question. Some energy levels for a hydrogen atom are shown. What is the ratio of wavelength emitted in the transition X divided by the wavelength emitted in the transition Y? Okay, so the transition X, the electron is going from 2 to 1, and for Y it is going from 3 to 1. So we want to find the wavelength. So how can we relate this thing? Obviously, we have to find first of all the energy gap between the two shells. And when the electron is making this transition, the energy is getting emitted from that. And from there, we can equate this energy with hc by lambda, and we will find the value of the wavelength, and we can find the ratio. There is no shortcut for that. This is the only thing that we have to do. But let me tell you one more thing now, like the things that you have to note now. First of all, you must be remembering that the formula for the total energy of the electron in any shell is given by negative 13.6 z square by n square ev. So z is the atomic number, which is 1 for the hydrogen, so you can clearly get rid of this. So, and be very careful that the unit is electron volt, it is not joule. Now, so this will be the total energy level and total energy, and accordingly we can find the energy for 1, 2 and 3. But because this is the case of hydrogen atom, you can even remember those. For example, I'm remembering all the energy levels. You see, this energy will come out to be negative 13.6. This is coming out to be negative 3.4, and it will be negative 1.151 ev. So this is how the energies are distributed. Well, n is equal to 4, it is negative 0.84, by the way. So I remember these four values, but anyways, we are concerned only with 1, 2, 3. So now let us go for the transition for y. So transition for y is going from 3 to 1. So what is the energy gap between 3 to 1? So it will be this minus this, and we are interested only in the magnitude, by the way. So one will be taken positive, another will be negative. So we can take 13.6 minus 1.51. So that will come out to be, because we are having calculator with us, 1.51, yes, so 12.09. Yeah. And what is the energy gap for x? This is for y. So it will be this minus this. So you can say 13.6 minus 3.4. Yes. So my answer is 10.2. Okay, so after finding these energy gaps, now we can find the wavelength. Like the photon will be emitted from y, so that photon will be having this energy. So you can find the wavelength from that. So it will be 12.09 is equal to hc by lambda. So I'm just taking it as lambda in the case of y, hc divided by 12.09. Similarly, lambda x will be hc divided by 10.2. Yes. So we want to find the ratio here for the wavelength of x divided by y. So it will be this divided by this. So they are inversely proportional. So that will be 12.09 divided by 10.2. So clearly it is neither A nor D. So these two options are clearly out. And this value is definitely coming out to be greater than 1. So the answer will be C, that is 32 by 27, because this value is lesser than 1. So this is how we do this question, dear students. Thanks for watching the video. This is Professor Varun. Please share the video with all your friends. Also join the YouTube channel to access the solutions for paper